Statistical Process Control is a great tool to tell you when you need to do something about your process. But actually its biggest strength is that it tells you when not to touch your process. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today we're talking about a statistical tool, a Six Sigma type of tool, SPC, or Statistical Process Control. Now, these are those control charts that you can also do without all the statistics behind it. It's a process control chart where you plot what the outcome of your process is, your output, like a product length or a weight or a moisture content or whatever, right? So there is some characteristic that you follow. Now, with the statistical process control, we use statistics and specifically the normal distribution and the idea that any process, even if you keep the inputs the same, will have some noise, some naturally occurring variation in the output. And we're going to find that variation. So we're going to analyze our process, see what is natural, what is common cause variation in SPC terms for this process, and we're going to tell our operators to not react to any variation that is within those normal bandwidths. Now, as you know, it is more common to have a little bit of variation than it is to have those larger peaks. And that is what SPC takes into account. So it assumes a normal variation, a normal distribution of your output characteristic. And because we have these statistics, so that's where it sort of steps away from putting a control chart in place more or less based on some range you ever set or tolerances, specifications, for instance, do not figure into this chart, but we will get to them in the second part of the video. This is purely calculated from how the process behaves. And we will then say there are these upper and lower control limits. When the process goes over, so when you have an output characteristic that is outside the control limits, either over or under the lower control limit, that process has probably shifted. We should act. Now, we also know, and it's usually put here as A, B, and C areas. You will see, by the way, if you Google this with the colors in, most people will put the red here in A and then the yellow or the orange in B. I don't really like that because red to me says immediately act. It is outside of the control limits. That is when you immediately act. And there are these rules that say, if 2 out of 3 points are in that A area, you also investigate. If it is 4 out of 5 in the B area, if it's 9 in the C. So there are some extra rules. All of those rules, what they basically do is they look at a normal distribution, and based on what they see, they make a judgment call. Is this still logical to get these measurement points if we would really have this normal distribution centered around here? Or is it just too strange, right? If you get a couple of values here, one maybe, but a couple after another, that is so unlikely that a centered normal distribution would do that. Almost certainly our process has shifted up. So it's not about that one product that we have. This is not a quality control, right? We are not checking each of these single batches or single samples. We are trying with this sampling to determine if the center of our process, so most of the products are made here and they are centered, averaged on that center, if our process is still centered, or that the whole process just drifted up a bit, drifted down a bit, away from its normal position. Because then we will find too many points in the higher areas, or alternatively too many in the lower areas, right? That is what SPC does. That is also what most people focus on. But the main thing, in my experience, that SPC does is to invert that thinking. It basically says, when you're hitting in that nice center area, and also when you are not triggering any of the rules, right? You have this whole rule package of SPC. You can pick 1, 2, 4, even 8, although 8 I would never use in the daily practice. It's 1, 2, maybe 3, maybe 4. And if those rules are not triggered, that means that your process is still centered. So sort of turn around the thinking of SPC. If you did your statistical calculations and your data gathering and stuff like that, the whole preparation implementation correctly, you will have a very powerful system telling the operator when not to do anything with the process, because it is still centered. That is key information. So when you are implementing SPC, make sure that that is one of the biggest messages you get across. If SPC rules are not triggered, leave the process alone, right? Don't start correcting things because you got one of these values, for instance, very close to a control limit. Operator traditionally thinking, I say, ooh, it's quite high, let me correct the whole process down. No, if it's only one, we consider it chance. The thing is, if we get one outside of the limits, we will act. Now, even then, the acting is first check that your basic conditions are in place. So redo all of those checks that you sort of already do, right? Your daily and weekly checks, your material checks. Better redo them before you start changing the process too much. But if it's not in there, do change the process. Change the parameters in a hopefully predefined way. And hopefully that means when you implement this at your factory, you should do the pre-defining of the action, right? Homework for you when you're implementing SPC. But okay, so it does say now you need to check your process, but then SPC itself doesn't really guide you where you should check, what you should check, how much you should correct, if any. So it's not that great a tool. It's not such a new tool for that. It is very similar to traditional control charts, and it says, oh, operator, you need to do something. What it is great at is giving you a very good system to tell the operator when not to touch anything. Now, what I also promised him is to go into specifications. See, these limits and even this center, they are not based on specifications. They are not what you would like your process to do. No, they are calculated from what your process is currently doing. So you are just looking at your process and you're calculating, this is 3 standard deviations from this average that I found to be happening in my process. And there's a slightly more complicated calculation to do that, because it looks at a short-term variation, but that's basically what it's doing. So we are steering the process based on what we know the process can do. Now, if our specification limits are pretty tight, and honestly, we sort of have a not so capable process, right? So let me also draw in the red specification lines. What happens now, right? When we cross a specification line, are we going to touch the process? What do you think? So when we do at that point, did I have to adjust the process, or at least go and investigate everything? Your quality department will probably say yes. Your manager will probably say yes, because you are producing defects. The knowledge you have of your process tells you that this, unfortunately, is all within the bounds of normal process behavior. So your best bet is to leave it alone. Now, those are the statistics. But that, of course, is not human emotion. When we are producing defects, and you come to your management, your quality department, your finance people, and you say, "No, we're not going to touch anything on that line because, you know, this is sort of expected of our process." 90% of them are going to lose their mind, unless they are very well versed in Six Sigma TPM style of thinking, and they trust this process, and you can really show it to them. They are not going to like this. Operators will also not like this. Not acting when something is clearly going wrong is not a nice thing. So when does SPC have a much better chance of success? That is if you can make sure that we are going to change that process, right? We're going to investigate the process. We're going to improve how stable it is. We're going to change some settings around, do a design of experiment, find the best, most stable settings, get ourselves to a nice optimum, retrain people, find a better method, whatever is needed. This is not easy. So remember that getting process variation down is one of the harder things you can do within continuous improvement. That is why you have all the Six Sigma tools, except for a bit of statistics. So let's say we can improve the process. Now we have a much more capable process. We have reanalyzed it. We have analyzed again what the process is doing right now, right? So this is not because we want the control limits to be lower. Never put the control limits just within specifications because you like it. No, you measure again your 30 subgroups or your 50 individual samples at least of the process behaving after you improved it. And then you again calculate the SPC limits, and if they come out to be less than, so less variation, closer to the mean than the specifications, then you've got a much better system that can also work for you. The statistics have not changed. These limits, everything was working perfectly fine. It's just that people will not accept it. So how far should you go? Well, if you are a bit familiar with CPK, it's basically sort of doing the same thing, right? These are 3 standard deviations. What you would really like to aim for, and this is fully in line with, okay, maybe not Six Sigma thinking, it's 4 Sigma thinking, there's a spoiler, but it is fully in line with the concept of Six Sigma. Make sure that your process is capable of producing seriously within your spec limits. These control limits of SPC are basically plus and minus 3 standard deviations of your process, right? So ideal is to have a process that is so capable that if you check how many standard deviations fit between the mean and the specifications, the tolerances, it would be 4. That will bring you to have more room within your specification than 99.7% of your distribution, but it's not about the 99.7. It is about when do you detect process shift. So the process needs to shift a bit before you have a good chance of detecting it. It needs to shift about 1.5, maybe 2, maybe sort of 1 standard deviations in any direction before you can really hope to see it in a relatively short period. And when you calculate this, basically this comes down to 4 divided by 3. It comes down to a CPK of 1.33. That is when SPC will function super. SPC and better as well. If you have 1.5, 1.62 CPK, SPC will be wonderful. Implement it, don't think about it, use the rules. When you are at a CPK of 1, so basically your process is barely capable of meeting specifications, that is the moment when you can start to use it as well, right? So, because you will have the same premise. It's not ideal, but you can start to use it with some guidance. As long as your control limits are wider than your specification limits, continue working on the process. You may implement SPC, but continue working on that process. It will give you much better returns. Now, what do we try to get from this system is that we get these 3 levels. And here I sort of drew them in not very nicely. Let me draw a different sort of traffic light that you want to use when you implement SPC in your factory. You want to go for a 3-tier sort of system in your process control. So this is for the operator. When you trigger specification limits, That's the red signal. When you trigger only SPC limits but not specifications, you get your orange. And when you do not trigger your SPC limits, so there's no alarm at all, you continue on green. Green means continue producing. Nothing's wrong. The yellow or orange, it means, so it comes from an alarm of SPC that might be, right? This one, so it could here in the new situation be at any point here, but it could also be if you have this, right? So 2 out of 3, or any of the rules that you implement in your company. So when SPC tells you your process has shifted, you get this yellow light. That means you act on the process. And when you get a red light, you're outside of your specification, you act on the product and the process. Because in this situation, you are out of both, right? This one point would already trigger SPC. Outside of the specs, you definitely also trigger it. This is another reason why, in theory, you don't need to have a link between specs and SPC limits, but in practice you do. You want to have tighter SPC limits. So you want to have a process that is capable, higher than CPK of 1. It can work from 1, but the farther you get above it, the easier it becomes. And then you train your operators on these 3 limits. Good, don't touch it. Action limit, act on the process. Blocking limit, act on the product. So that might really be a formal blocking. It might also be as simple as I have to communicate to the next department because they need to sort of reset, retool, rework something to get that process further in the product further in the process. But something needs to be done with the product. Here, only the process. But you do have to do something with the process. Even though the product is good, product will go to the next step in the process line. You have to act on your process, because if you don't, it will drift even further and it will become red, and that's not what we want. This is what SPC is giving us as a tool. It does not share where the problem is, what the problem is, not even really how big the problem is. If you get this, your deviation is not bigger than if you get 2 of these. It's roughly the same, but it's all more I found a significant change of what I expect, but I don't know how big the change is. SPC does not tell you how big the change is. It tells you, go about your business. And that is the most important difference SPC will make to your operation. When you need to act on the process to prevent future problems, or, and this is typical quality management, when you already have a problem and you need to act on product and process. I hope that clarified the main goal of SPC for your operation and will strengthen your quality management. If it did, or if it at least got you to think about it, don't forget to hit that like button. I really like it. It's also good for the algorithm. And if you have questions about SPC or any of the other tools, drop me a comment below. Right? Also, if you think that maybe it's time to make a next course on SPC, let me know. I'm sort of brainstorming what the next online course will be about. So you can weigh in on that if you want to. For now, I wish you the best of luck implementing SPC and using it in your operation. And as always, don't forget to also enjoy the continuous improvement journey.